Hi, this video is on about AI fault detection in power systems using MATLAB. What happens when a power line fails? Can artificially detect electrical faster than humans? Today we are building an AI-powered fault detection system in MATLAB, fully interactive and visually and real time. So here we are building a smart GUI graphical user interference with buttons for each type of fault. First condition is no fault. Second one is line to ground. Third, line to line fault. Fourth one, three-phase fault. And when we click a button, it generates fault data, plots calm waveforms, and feed artificial neural networks. Let's break down it technically. For each button, triggers a signal generator for IA, IB, IC. The three-phase currents will simulate the real behavior of using sine waves, frequency spikes, and harmonic distortion. The simulated LG fault. Notice how only phase A is distorted. The ANN picks up immediately. How that the AI works? We simply use it here. Feed forward neural network, which uses root mean square for each phase. The ANN learns pattern across different faults and classify them. Now to test, first we'll run the code. So when we run the code, first I'll select no fault. Now let's hit with LL fault. So what's exactly the symmetrical distortions we can expect in a three-phase circuit fault? It is fast, accurate, and repeatable. This is not just for academics, but it is virtually required for the grids connected across the country. With AI grid integration, the faults can be predicted fast and isolate faster, reducing the blackouts and protecting the equipment. And I'll provide the code for this also. See, when there is no fault, you can check no fault, LG fault, three-phase fault, NL fault. So here we use some key concepts that are GUI, graphical user interface, in that we use UI figure and UI button for user interaction, and signal generator sign bracket, SIN bracket, and harmonics for fault simulation, feature extraction, RMS brackets for neural network input, and AI model, that is feed forward neural network used for fault classification and visualization. Plot, we have plotted the real-time waveforms in the display. Okay, so we will check each and everything now. The GUI creation is the figure UI is equals to figure UI control style text string position. This everything can be set by some individual easily just for visual interaction. Each button simulates a different type of fault. Okay, you can see the UI button 200, 250, 130. And next thing about fault simulation logic. Okay, in fault simulation logic, the function generates the three-phase variant waveforms IA, IB, IC for each fault type, and normal operation IA, IB, IC. Sine 2 pi ft, sine 2 pi ft minus 2 pi by 3, sine 2 pi ft plus 2 pi by 3. This is the normal operation in a three-phase thing. Each phase is differed by 120 degrees of phase shift. But in LG fault, only phase A get distorted. That means IA is equals to sine 2 pi ft plus 0.7 into sine 6 pi ft. In LL fault, two phases are affected. That is IA sine 2 pi ft plus zero point 0.5 sine 4 pi ft, IB sine 2 pi ft minus 2 pi by 3 plus zero point 0.5 into sine 4 pi by ft. In phase 3, triple L fault, all phases are affected. You can observe here, all phases are affected. Then I've wrote some formula taken from standard books. This harmonic distortion is due to short circuiting in the short circuits. Mainly, it's always short circuit. RMS values are used here for ANN inputs. It is a simple but effective feature for fault classification. In ANN, net is equal to feed forward 10. It is one hidden layer with 10 neurons. We can use different number of neurons, but to get proper accuracy after running code different many times, where I believe this is the best accuracy I can get using this. The training data have taken this. The train is saved at that location. You can see in the code here. Okay, visually to all understand the plots. What is happening? I've taken here plot AXDNAR linked with user title, user input, and AI predicted. So this is what it is all about. Once again, I run the code. You can check here. Select a type of fault. When there is no fault, no fault, LG fault, AI prediction, no fault, user input, three-phase fault. You can see the graphic distraction. Okay. In next video, I'll come with some more meaningful videos. Okay. And I want to clearly know you that I want to know that the final outcome is when we can successfully create a real-time powered fault detection system using MATLAB with interactive GUI, real-time signal generation, AI prediction used to easily classify fault LG, double L, triple L fault. Prediction is instant based on RMS vectors, dynamic visualization. Okay, this is the complete thing of high fault prediction. Thank you.